Hello student, welcome to the last topic from the magnetic effects of current. Now we are studying about the conversion of a galvanometer into an ammeter. We know that ammeter is a device which is connected in series in an electric circuit to measure the amount of the current passing through the circuit. An ideal ammeter has the property that it should have zero resistance. Reason, because it is present in series in the circuit. So when it is connected in series with the circuit, then the resistance of the galvanometer coil adds some more amount of resistance into the total resistance of the circuit, due to which the current flowing in the circuit will reduce. So in this way, if a galvanometer is directly connected or an ammeter is connected in the circuit in series to measure the current, due to overall increase in the resistance of the circuit, the current which we intend to measure, it will decrease. So we will get an incorrect measurement of the electric current. So in order to convert a galvanometer into an ammeter, what we should do, we should reduce the resistance of the galvanometer further, so that the amount of electric current drawn by the ammeter, it should not change. That is possible when it should not change much the resistance of the electric circuit. So we can do this by converting a galvanometer and ammeter by connecting a very small value of resistance in parallel with the galvanometer coil. This small resistance which is added in parallel with the galvanometer coil, it is known as the shunt resistance. So here in the circuit, you can see that this is the S is a shunt resistance which is added with the galvanometer resistance, which is indicated by the letter G over here, because both are connected in parallel. So overall resistance will be even smaller than the value of the S, which is a property of the parallel circuit. Here the resistance of the galvanometer coil we are indicating with capital G. Ig we are indicating as a full scale deflection current, means Ig is the maximum current which we can pass through a normal galvanometer. So at this current, the pointer attached to the galvanometer will show full scale deflection. So any current higher than this value Ig is going to damage the galvanometer coil by producing heat inside it. So we cannot pass a current higher than that of Ig value from the galvanometer. The shunt resistance which is connected in parallel with the galvanometer is S. Let we want to increase the range of this ammeter to measure the current from 0 ampere to the I ampere, which is far much greater as compared to the value of the full scale deflection current. So in order to measure how much S should be connected in parallel with the galvanometer so that it can be converted into a required range of 0 to I ampere, we look from the circuit that because both resistances S as well as G are in parallel with each other, this means that potential difference across the shunt resistance and across the galvanometer is also same. So potential difference across the shunt is I minus Ig into S, which is equal to potential difference across the galvanometer, which is equal to Ig into G. So when I current reaches at the node A, it divides into two parts. Safe limit of the current Ig passes through the galvanometer, and rest of the current I minus Ig is passing through the shunt. So this we can rewrite as S is equal to Ig divided by I minus Ig into G. So using this resistance, this equation, we can find out the required shunt resistance with which we can convert a galvanometer into ammeter. That means, in other words, we can increase the range of the ampere meter from Ig ampere into the I ampere. Next is the last topic, which is the conversion of a galvanometer into a voltmeter. Voltmeter is connected in parallel in a circuit across any particular element in a circuit to measure the voltage present across it. An ideal voltmeter should have infinite resistance. Reason, because it is present in the parallel across the element for which it has to measure the voltage. So when it will be connected in parallel to measure the potential difference, what it will do, due to the parallel circuit, it will draw a small amount of electric circuit which was supposed to pass through the element for which we have to measure the potential difference. Because it will draw some amount of the current through the circuit when connected in parallel, so the current which was passing from the element across which we had to measure the potential difference, it is going to decrease. So if potential current passing through that element decreases, it means that potential difference developed across that element will also decrease. So this incorrect measurement should not take place. For that, an ideal voltmeter must not draw any amount of electric current for which it must have infinite resistance. But we know that infinite resistance galvanometer manufacturing is not possible. So what we do, the real actual voltmeters, they have very high value of the resistance which is connected in series with the galvanometer coil. So here in the circuit, if R is that very high value of the resistance which is connected in series with the galvanometer coil, then we can convert a galvanometer into a voltmeter of the required range. So if the resistance of galvanometer coil we indicate with capital G, Ig is again full scale deflection current, and R is that resistance which must be connected in order to convert this galvanometer into a voltmeter of Z range 0 to V voltmeter, 0 to V volt. In that case, we can see that both R and G are in series, and when both are in series, the total resistance is equal to R plus G. Now because both are in series, this means that the full scale deflection current Ig passing through both of them is also same. This means that current must not go beyond the value of Ig, otherwise it will damage the coil. So in this case, because both are present in the series, so using Ohm's law, the total current running in the circuit Ig, it is equal to total potential difference divided by total resistance. Total potential difference we want to measure is capital V, it divided by total resistance, which is R plus G. Now the value of Ig is very small, it is of the order of few milliamperes. So in this case, if we directly apply potential difference V across the terminals of a simple galvanometer, the current running through the galvanometer coil, it will be of the order of few amperes, which will burn the galvanometer coil. So the main purpose of the R in series with the galvanometer coil is that when a high value of potential difference is applied across the galvanometer into a series combination of galvanometer resistance G and the resistance external R connected with it, the current running through the circuit, it must not go beyond value of Ig. So we can rearrange this equation in order to write the value of R, which will be equal to V over Ig minus G. So using this equation, we can find out that value of the resistance which must be connected in series with the galvanometer coil, so that it can measure a potential difference from 0 to V volt without damaging the coil. Thank you.